This last example is perhaps the trickiest, at least from my perspective. So we have a spotlight on a ground. Okay, so let's get our diagram going. Okay, so step 2, spotlight on the ground, shines on a wall. Okay, so here's the wall. We're assuming it's perfectly vertical, and the wall is 12 meters away. Okay, and here would be kind of the shadow that it would make. Okay, and if a 2-meter tall man, okay, so here's the man, and we know that he is 2 meters, okay, walks from the spotlight towards the building, okay, so he's going this way at a speed of 1.6 meters per second. We want to know how fast the length of his shadow, okay, so to be clear, kind of here would be his shadow. How fast is the length of the shadow on the building decreasing when he is 4 meters away? So we know that this distance here would be 4 meters. Okay. So, we know that we also know that this is 2 meters. Okay, I'm not seeing the problem here yet. I don't see the geometry isn't helping me write up my equation. Okay, because I have step 3 and I still have step 4. Okay, how fast is the length of the shadow building decreasing? So if we call this whole thing y, we don't know the height, but we're interested in how fast the length of the shadow is decreasing, and so that's really looking at this part. So this is currently y minus 2, but we're interested in the dy dt. Okay, so we're interested in this. Okay, we don't know what y is. We don't know how tall or how far this shines on a wall yet. We know currently, if we think about x, it is 4, like he's currently a distance of 4 away, and we also know that his speed, he is moving towards the wall at 1.6 meters per second, and I guess in the context of this problem, I'm going to introduce a negative, okay, because we'll see. We have to maybe carefully define what x is, and I'm going to say x is the distance from the wall, okay, distance from wall. So that is why I have a negative, because the distance from the wall is decreasing. Okay, so again, I still don't see what's going on geometrically here, and that's because we need to maybe zoom out just a little bit. Okay, if we think carefully, we have one large right triangle, right? And we know that it's 12. The horizontal component is 12, vertical component is y. Okay, but I also see another smaller right triangle, one that is right in here in blue. Okay, and so that's another right triangle. So if I think about that, then if this is 4, this would be 4 in a specific moment, right? But in general, this is x. So then in general, this would be 12 minus x. Okay, and so what I'm going to do is set up equations for similar triangles. Okay, what I'm going to say is that the vertical component of the big triangle, y, is to the horizontal component of the big triangle, 12, just as the vertical component of the small triangle, 12, is to the horizontal component of the smaller triangle, 12 minus x. Okay, and with this you can certainly rearrange. You can cross multiply, you can get 12 or 24 rather, is equal to y times 12 minus x. This is fine. And then at this point, this is where I would say let's introduce a time derivative. Okay, so if I introduce a time derivative, I'd have 0 is equal to, and then here we have a product, so I have to do the product rule. Y times negative dx dt plus dy dt times 12 minus x. Okay, and so then now I have to substitute in, but the thing is I still don't know what y is, right? I never found it out from above. That's where I need to use my equation here. So I don't know what y is, but I know that for the smaller triangle, if x is 4, then I have 8, and this allows me to say that y is going to be 3. Okay, so now I can do that substitution in step 6. 0 is equal to 3 times negative 1.6 plus dy dt, which is what I want to find, and then 12 minus 4, or 8. And so then if I do this math, and this should be a plus, I forgot about that, but doing the math to solve for dy dt, I got negative 3/5. Okay, once you fully simplify. Okay, and this is consistent with the length of the shadow decreasing and all that. So I would just say the shadow is decreasing at a rate of negative 3/5 meters per second. Okay, so there we go. So this problem, it was a little different than the other ones. The formula didn't pop out at us and stare us in the face. So sometimes you might have to do a little bit more work with some of these, and certainly ask questions when you have them.